Okay, so it is the third question of the weekly contest 486. Pythagorean distance node in a tree. You are given an integer n and an undirected tree with n nodes number from 0 to n minus 1. The tree is represented by a 2-day array that is giving edges of length n minus 1, where edge I is ui vi indicates an undirected edge between u and v. Okay, and you are given three distinct targets nodes x, y, and z. For any node u in the tree, dx is the distance from u, okay, dy is the distance from y, and dz is the distance from the node z. The node u is called special if all the distance follows a Pythagorean triplet. What is Pythagorean triplet? A square plus b square should be equal to c square, and this abc should be in the sorted order. So the distance between two nodes is a tree. Okay, number of edges between that. So what we have to return an integer denoting the number of special nodes in the tree. Okay, the tree which follows this Pythagorean formula, a square plus b square is equal to c square. Okay, so let's treat this as a undirected graph. So for undirected graph, we simply create a adjacent matrix. And how we create that? So first we can say for I in range n. Okay, now we will go through the edges for u comma v in edges. As it is undirected graph, we have to create edge from u to v and v to u. So adjacent matrix of u dot append v and adjacent matrix of v dot append u. Okay, so we have created a adjacent matrix. Now what can we do? We can simply put answer is equal to 0. Let's put answer initially at 0, and then we can create this dx variable which will keep the distance of each node from the x node. So let's define a function far which will calculate the distance of each node from dx. Similarly for dy, distance of each node from the yth node. Similarly for dz, distance of each node from z node. Now simply we will go for I in range and we will go through each nodes and we will calculate e comma b comma c for them, which is nothing but let's get a dx of I, means distance of ith node from the x node. Simply dy of I, which is distance of y node, distance of ith node from the y node. Similarly dz of I, distance of ith node from the z node, and this should be sorted as per the question. So let's sort this out. Sorted. And now let's check if e cross a plus b cross b is equal to c cross c, then we can simply increment our answer plus is equal to 1, and at last we can simply return answer. Okay, so only part left in our logic is creating this far. So we will use Dijkstra's algorithm here to calculate the distance. So for that we should import heap here, which is heap q. Now simply let's create function far. Define far, we can give it a name start. So initially we can mark distance of each node is equal to float infinity for I in range n, and as we are starting from the start node, then the distance of start from the start is 0. So we will simply mark distance of start is equal to 0. Distance of start is, now we will simply create a heap. So pq, and we will post this start and its value, its distance from the start, in the heap q. So let's put that heap q dot heap post in heap q dot heap post in nothing but pq pq dot heap queue pq, and the starting value is 0, and we are starting from this. So this has been, now we will simply traverse. So while pq distance comma node is simply pop out the heap queue. So heap queue dot heap perform which array pq. Now go through this adjacent matrix in the neighbors of this node. So for neighbor in adjacent list of this particular adjacent list of this particular node, and the way here weight is not given, means weight is just 1, as we are counting the number of edges, means weight of each edge is equal to 1. So if distance plus 1 is less than distance at neighbor, that means we have got the shorter distance. So we will simply update this distance at neighbor is equal to distance plus 1, and we will push that in the heap queue. So heap queue dot heap push pq, and what will be pushed? Distance of neighbor which we have calculated, comma neighbor the node itself. Simply we can return the distance array which we have calculated. So every time we are calling this function 3 times for finding the distance from the x node of each node, similarly for y and z, and then checking which all nodes satisfy this condition, and then returning finally the answer. So let's try to run this now. Name adjacent list. Oh, we have mentioned adjacent matrix here, and we have changed this to adjacent list, adjacent mat this. Let's try to run now. Okay, so test cases have been passed. Let's try to submit this now and check if this works for all the test cases. Okay, so our code has run successfully. Thank you.